And our viewers, I'm sure, are also excited to hear from Mykola Kolomiiets. Hi, Mykola.
Hi.
How are you doing out there?
Ooh, neat background.
I'm fine. Just listen speech from the Evgeny, and this is great.
Nice.
Try to do the same.
Awesome, awesome. Well, we are sure that you'll do your best and everything will go smoothly. And we are also excited to hear from you. So the floor is yours.
And we are eager to hear about experience in Debezium.
Yep.
Today I will talk about our experience with Debezium and why Debezium is a grateful technology in your business. First of all, you need to understand that Debezium is working with the data. And in our information age, data is a core, is some important part for your business, for your product. So Debezium helps to work your product the best way. And today I will cover more technical details overview of Debezium, how it works. Also, I try to cover Outbox Pattern, how it helps and why it was been important in our case. How and why we choose Debezium based on Outbox Pattern and Debezium especially, and show you some metrics, how Debezium works, and some performance tests. I want to start from the fundamental things of the Debezium. What is a core pattern to create this technology? And it is a capture data changes. This pattern is talking about stream changes from one source database, some processing, update, transform data, and store this data to second target database. So that means we will have some automatically process on the database level for capturing data and store to some target place. Target place can be not only database, that can be some Kafka topics or something else. We don't need to update the application and maintain this feature on the application level. So we just configure some tools to listen these changes, and our application just focusing on business features, on features itself. And Debezium really help with that. And now I will talk about more marketing, maybe part of the Debezium, and do more with your data. So that means Debezium helps work with data, and it is monitoring and capturing and streaming data on the database level. So you don't need to update your application. You simplify your apps, and you are writing code for business feature. And don't worry about infrastructure code, and just don't need to maintain this infrastructure level, because Debezium is doing it. Also, never miss a beat. Debezium is monitoring changes into database, and if your service is broke and will up, data never miss a beat and will be the same order that was been stored into database. So if order in your business very important, how data is changed, Debezium cover this point too. And react quickly. Debezium actually is working with Kafka, and together these tools can provide us very fast and very quickly providing data from your database, streaming these changes from your database. And you need to focus in only on business rules, and everything else will be covered Debezium and Kafka. And I will show you, it is a example of the architecture with Kafka and Debezium, and core block or core service is a Kafka connect with Debezium source connectors. It is a Debezium server that actually is listening changes from your databases and put messages events to Kafka topics. And you can also add Kafka connect with sync connectors to listen these changes and send and put or store this message to Elastic, Infinispan, and Data Warehouse. But actually, why is Kafka connector with Debezium source connectors is important and root this architecture? Because this service is listening changes by some technical details I will talk about it, and convert these changes into Kafka messages. It is important and really beautiful things. So you don't need to, in this part, write code, because you just set up Debezium and configure it. That's all. Everything else, Debezium is doing myself. Also, and really good thing of the Debezium, that Debezium can send message not only to Kafka topics, it can send messages to Redis, Amazon Kinesis, Pulsar, and Google PubSub. So, for example, if your project use, for example, Google Cloud Platform, use PubSub, and you don't want to start use Kafka, you can use Debezium and send message to Google PubSub, no problem. So Debezium provides us a lot of the things, a lot of the features to working with a lot of the databases and some target places where we can see these changes. And how Debezium is working, how Debezium is listening changes into your database, and this is pretty much simple for things, but it is a logical streaming replication. If we are talking about PostgreSQL, of course. So Debezium is listening logs or things for replications on the database level. If you're talking about Postgre and you want to start use Debezium for Postgre database, you need to turn on logical streaming replication. What is it? Logical streaming replication is process when data from master nodes replicated or streamed to slave node, and important thing, it is working by wall locks, write ahead locking. So after any operation into database, master database, database will write some write-ahead logs, wall logs, and send it to while sender send it to logical decoder, and slave node can subscribe on this logical decoder and listen any changes in the master node. And based on these write-ahead logs, replicate or restore state, data, and structure, of course, from the master nodes, master database. Actually, Debezium is listening the same logs and converting these changes to Kafka messages, to Kafka events into topics. So pretty much easy to configure, like us, just to create this configuration. Debezium is providing to us API to manage Debezium Server. We can see status of the connections. We can see status of connectors. We'll see all the connectors that we have. Also, we can create or update, of course, the connectors. It is a simple example how to configure of the connector. We can just provide some name. If we can see understanding name for us. Also in config section, we need to set what exactly connector is. If we want to use, for example, MySQL connector, we need to set MySQL connector. For another databases, we set another class. Also, we need to set connections to the database. I mean, we need to set host name, port, user, password, server name. We can include or exclude something that we don't need to stream. We can include database, we can include tables, we can exclude database and tables that we don't need to see. And we need to provide access to Kafka, provide some connections, and what exactly topic names we want to see. For example, if we want to see schema changes, that inventory, that means that we by this topic we can see updated structure of the database. And how this configuration connection converting to Kafka messages and Kafka, how it looks. After setup of the connector, when we create inventory database, for example, and create few tables, when we insert or update data into this table, it is converted to topic, and topic names will be DB server. It is a server name. Second word, it is a database name, and last one, it is a table name. And we can use this template to understand what exactly topics was being created, will be created, and we can subscribe on these topics and listen changes into this table. Pretty much simple and easy to set up. What exactly following connectors we have? As you can see, a lot of the databases is can be used by Debezium. So Debezium can connect to this database and streaming changes. So I believe that this set of the databases cover a lot of the projects and products that we have. Also, who is using the Debezium? you can see that some big product is using Debezium, and that means I believe that Debezium is very popular, a stable and grateful technology if this big product uses it. But return to our experience with Debezium. First of all, we need to understand that we didn't use Debezium in the start working on the project. So we tried to use another way for streaming data changes. And of course, we faced it with a lot of the problems, issues. And after that, we have started to use Debezium. First of all, we have microservice architecture, and we need to stream data from one service to another by some business rules. And after working and trying to use another way for streaming changes, we decided that we need to some pattern that help us. And first of all, it was being Outbox Pattern. Outbox Pattern helps us to store and resend messages and stable way to working with data. And also Debezium actually has in official documentation of the Debezium have blogs about Outbox Pattern. So Debezium tell us that you can use Outbox Pattern with Debezium. What is it? Outbox Pattern is a way to safely and reliably exchange data between multiple microservices. And Outbox Pattern implementation avoids inconsistency between services internally state and state in events consumed by services that need the same data. Simple words, Outbox Pattern provide functionality to safely state data from one service to another. So all data that exists into service is stored into Outbox. In this diagram, you can see Outbox Table. So all the changes is stored to this Outbox Table. We have some columns to describe this Outbox. It is an aggregate type. It can be just an entity name. Aggregate ID, it is a unique identifier of this entity. Type, it is a type of the operation on this or action on this entity. For example, order created. It means that order was being created. And payload, it is an entity itself. It is a data and some model for this entity. And Debezium actually can convert these rows after we inserted these rows, converted to a message and put to topic based on column information. So based on aggregate type and type, Debezium can put this message to the topics that we need. And we can configure this too. So I will show you a little bit after. And based on this pattern, you can see why our previously implementation is not working. What we had? We are using replication pattern to communicate between services. We are using microservice architecture, and all services are being owners on one entity, one big or major entity. And based on this, we got too many services, because if we have a big project, and for each major entity was being created services. Now maybe count of this 100 services, and we try to find a way to communicate between these services, because for example, if you need to create some entity, you need to have information about another entity for validation, for example, and how to do it. And we start use a replication pattern for use data entire system for communication between services. How it works? For example, you have two services, service A and service B, and entity A has foreign key on the entity B, and you need services A needs some information about entity B for validation create process, for example. And how it works? We try to create entity B into services B, and after inserted data into database, service B will send a message into Kafka topic that I have created entity B, and it's all. Service A is subscribing on this topic and listening it, and store this information, this data about entity B to service A database, and can use this data when we need. And actually, why is not it working? Cannot, or just difficult, send a message to Kafka and update changes in the database by the only one transaction. What does it mean? If you update update entity or insert the entity to the database, service B send message to Kafka, and if service B cannot send somehow, I don't know, maybe something goes wrong, and cannot send this message to Kafka, data is inconsistency between service A and service B, because entity B was been changed in service B, but did it in service A. So we need to understand that if we cannot send message and tell another services that entity B was been changed, then we don't need to store these changes. We need to say that, hello, something is wrong. You need to, I don't know, maybe handle this. Second point, account of GTOs and models for working with the sending and processing message. It is not a big problem, but by some rules, we need to store entity B, but send to Kafka entity B plus something else, and increase count very big based on this strategy. And last point, and maybe major pain point for us, how to resend message in this case. And maybe one second part, how to resend message in the same order that we receive. So it is mean that, for example, service B has entity B, and if entity B changed some fields, we need to start some business process into service A. And after update entity B few times, we can lost these changes. And if we just resend actual state of this entity to service A, this business process will not be running. And it is a big problem in our business, in our product. And actually, of course, how to resend message. It is need to create API call to start to resend messages, or we need to manually somehow put these messages to Kafka. And with this helps Outbox Pattern, Outbox Table. So Outbox Table in our case looks like that. And you can see that Outbox Table is not have a constant structure. It can be expanded, it can be modified somehow, or maybe you can use small number of the columns. And if you need to add some fields, some columns, you can do it. And in our case, we added user info and created user info. It is a JSON string of 2. It is information about user who did these changes, and created when actually it was. Also aggregate ID, as told, it is the ID of the entity. Aggregate type, it is not exactly entity. Type, action of this entity, and payload, it is the model of this entity. And after we start to use Outbox Pattern and start to use Debezium to streaming these changes to Kafka, we are receiving this first iteration, our Outbox plus Debezium implementation. So you can see that we have a lot of them. Open Debezium connector to each database that we have. And after we did that, we have faced with new issues, new problems. And first of it is a configuration for each database. So we need to maintain all the JSONs to configure connector. We need to create new one if we add some new service. We need to update all the JSONs if we change, for example, template of the topics, etc. Also, monitoring all open connectors. You need to make sure that on the environment, all connectors are working fine. Because if some connector will be broke, this entity will not be replicated. So it's very big problem in our system. And last one, some cloud native services have limitation on logical replication feature for PostgreSQL. And it tells us that we cannot have a big count of the open connectors. And based on this, some services, some connectors didn't send replicated message. And after we got new part of the problems, we actually found new solution, and it is create a single database for storing all Outbox tables and messages. Based on that, we need only one connector. So we need to configure and maintain and monitor only one Debezium connector. Of course, we update some configuration, but it's not a big deal. And you can see that all our databases or services send store messages, Outbox messages, into one, for example, database data reader that have Outbox tables for all of our existing services. And these tables will convert to each topics that we need based on some rules. But how to maintain it, how to do it? I mean, store these messages to one database. And answer on this is foreign key data wrapper. PostgreSQL is providing some feature for connect or access data stored in external PostgreSQL server. So we can insert data to our Outbox table from our database and don't need to update and maintain application itself and worry about that on all levels. So we need to just update our implementation on database level for storing Outbox messages to some external database server. And actually, Debezium will subscribe on external database for listening changes. How looks configuration for single connector after these changes? Table field MNK and payload, it is just for understand what exactly is important in our Outbox table, and transform fields describe how to message is converted, how it maps, how to transform. First, a major maybe field, it is a transform.outbox.row.by.field. It is an aggregate type. We take value from this column, and in the next field is describing how topics will look, and based on aggregate type, we put this value into variable routed by value. So our topics will look application.outbox.aggregate type that exists in this Outbox table. And this is very powerful transforms that really help us just to put messages and don't worry about which topic will be used. And next field for configuration, it is just maps payload or the row from the Outbox table to a message body. And we told that created should be created, type should be type, aggregate ID should be aggregate caps ID. That means that we can actually put another field names, another structure maybe for our business. For example, if you need to some another field names, if this data can use not by only one system, for example. You can update and create these rules for mapping. Next next field is describing IDs key of our entity for converting to right way. But when we start working with Debezium and our services increase, we face it with some limitation of the development process and some limitations where start using environment and environment start use more people than we have on our team. First, it is run a lot of the services. So for working on some feature, for example, order, we need to run services for create this order. It is product, user, inventory, credits, and something else. It is a big list. And our machines that we are working really work hard. And if we open task management, we can see that CPU and RAM has a 100% loaded. So it is and we need to add memory, update our machines to working with this count of services. Also, Debezium in the Docker, especially, has some strange behavior, and sometimes just turn off and didn't send a message. So we put message to Outbox Table, but from the Outbox message, from the Outbox Table, we didn't see a message in the Kafka topic. We are researching this problem, and right now we don't have a good progress in this way, but we found that this problem we face it only on the Docker. So if you set up a Debezium on your machine just application level without Docker, it is working fine. So this issue we see only on Docker. And last point, it is a problem not only for development, but it is a problem on the environment too. Replication has some small delay. It is delay from not only from create entity by the API and receiving these messages in another services. This delay between insert data or update data in your database and putting these message events to Kafka topic. So this delay when Debezium processing this data, listening this data itself. So this delay, it is Debezium processing delay. And I have a small Metrix result to see this delay. And first diagram shows us average by size used by 10 entity inserted per one transaction. So we inserted 10 entities and increase size of the messages in symbols. I mean, that's just count of symbols in a message. And you can see that when we increase size, delay increase to grow based on size of the message. And second diagram shows us how grows delay based on count of inserted entities in database. And you can see that if you send 10 on 100, this delay is the same. The same. But when you start send 1,000 on 10,000, delay increase very big. And you can see that from 1 second to almost 3.5 seconds, just when we start send more entities. So if it is important for your business send big data and or a lot of the count entities per one transaction, you will face it with some delay in Debezium. So after working with some tools that we have created by ourselves, I mean our way replication by the sending message to Kafka, and after start use Debezium, I would say that Debezium is the best maybe decision that we are. And I see that Debezium easy to integrate. So if you don't use it right now, way to start use Debezium is very short. So you need to just create configuration connector, and that's all. You don't need to big update your database. Of course, if you want to start use Outbox Pattern, you need to update your I don't know, maybe only database level too, if you are using functions to work in the data, or you need to update application to store Outbox messages. And after also grateful that we don't have infrastructure code for maintaining this part. So you don't need to worry about updating schema or structure of your database or application. You don't need to update somehow your Debezium, because Debezium put a new structure in working with that. And of course, see a really fast processing and really quickly work with the Kafka together. And maybe one minus for Debezium, I'm talking about Docker and working with the Docker, that sometimes we just lost messages and Debezium is turned off. But I hope that we will figure out it and maybe fix it in the future. And that's all from me. Thank you.
Okay, so I suppose you should have questions coming up for you in the chat.
Yep. First, does Debezium have competitors, and have you considered them as option? Maybe I'm not clear about question. If you can rephrase, it would be great. because I'm a little bit confused. And second, why didn't you use replica at DB level for entity instead of sync server Kafka? Yep. Second question. Yes, we are talking about start using database level replication, and just to forgot about sending messages, but we have a big but. First but it is that we sometimes need to start some business logic based on updating this entity. Of course, we can start use Kafka and we'll be okay with it. But when we are start use replication, looks like we resolve replication issue. I mean, just to use another data from another services and resolve some business rules, business processing, business feature based on this data. I mean, if we update orders, update order field status on from active to in process, we need to start another some business process. So it is good way if we just use data, but we need to handle some business process. And second point for this question, that we have another system that listen Kafka topics and use our data for some another processing, and we don't want to provide access to our database for this second project, and just send messages updating to Kafka. Yep. Next question: what we can do when connector will be broken? How we can avoid this situation? That is a great question. Right now, we create some job, some tools to monitoring this status of the connector, and if pulling API the Debezium and check health check, and if is broke, we have tools to create and build up a new instance of the Debezium and configure our database and start listening database after update. And old Debezium instance will be deleted. Of course, in this case, we will have some downtime, of course. And how we resolve it, I don't know right now. We actually are working on this too. What next question? What databases does Debezium support? Is that possible to create a custom connector for the storage? As I know about what databases, I have a slide. What exactly a list of the databases can be supported by Debezium. And about create a custom connector, as I know, we cannot do it. I mean, if you want to start listening some I don't know, for example, Azure storage table, you cannot do it. And oh, about first question, does have computers and have you considered them as option? We didn't look any another tools or another ways that can be the same like as Debezium. First of all, I didn't see the same technology with all of the list of features. So we didn't. Next question, what about the hierarchy of Debezium? Is that appropriate or for high-load tasks? I suppose yes, it is, but you need to understand that that you need to create architecture that that is ready for hierarchy. And first of all, if your application is designed by the right way and is ready, so Debezium is not be a bottleneck for that. Looks like that's all. Questions?
Thank you very much. It was a cool talk, and I'm sure our viewers will use all the information provided in their future work. Thank you. How did you like your experience performing here?
Actually, it is great experience. First of all, because this format, and we should be ready for anything that can be happens.
I agree. There are a lot of circumstances under which we both prepared for this conference and led it. And in any case, we are doing it. We are staying strong, and we are learning and letting learn others, right? Awesome.
Totally agree.
Awesome.
Did
you like your questions? The questions the audience asked?
Yes. Actually, I was been ready for these questions, because when I prepare my presentation, I know that maybe will be a question about hierarchy if my my presentation after topics about hierarchy. So,
well, great.
So yes, questions is great.
You got to prepare. And it seems like that would be what you would ask yourself, right? If you were the watcher.
Yep.
Awesome.
Yep.
Awesome. Thank you. It was a pleasure having you here. And we all wish you the greatest day ahead. And stay tuned for the next speeches. Maybe you'll find something interesting for yourself as well.
Of course.
Thank you.